All right. So in the last one, it was the addition rule, had to do with or. This one is the multiplication rule, and it really has to do with and. So write and in giant letters, because and means this. You ever get them confused, you can just think ordition, multiplication. It doesn't work. Nobody's ever going to remember it that way. If you ever forget, use your notes, because this class is open book. All right. Probably. So using the wording of and in a question of probability could examine the probability of a sequence of events. So sometimes it's going to be something, oftentimes it's going to be something and then something else. It will represent the probability of seeing some event and then, hence the and, some other event. And when we do that, we're going to use multiplication. So I'm getting really sick of these jelly beans. I don't even like jelly beans that much, but at least I want some different colors. We still only have 10 jelly beans. They've been touched a lot. From this set of 10 jelly beans, we're going to draw 2 jelly beans now. Oh, really leveling up now. 2 jelly beans now, okay? So if we draw these with replacement, and remember we talked about that earlier, if there's replacement, then the 2 pickings are independent of one another. But if we draw one and keep it out and then draw another one, oh, my green screen didn't like that, then they wouldn't be independent. So here, these are going to be independent events now. What's the probability of choosing a jelly bean that's green and then a jelly bean that's red? Good question. And the answer is this. There's other ways of coming about the answer, but I figured let's just use I'm not going to do the typical professor thing this time. Let's just use the property. If we have independent events, the probability of them both happening, one after the other, one and then the other, is just their multiplication, as long as they're independent. So because we have replacement, these are independent. So the probability of green and then red, a lot of times we denote it this way. This right here is green then red, is just going to be the probability that something is green times the probability that something is red, because there's replacement. Okay? Probability that it's green is going to be 3 out of 10. Probability that it's red is 4 out of 10. Combine these, that's 12 out of 100, or 12%. Because that second event, right? It doesn't matter what the first one was. We want it to be green. But since we're putting it back, we can just calculate the probability of any old pick being red. All right. If there is not replacement, it's a little different. We'll talk about that. So again, if we draw jelly beans with replacement, what's the probability of choosing a red jelly bean and then a purple jelly bean? And again, with replacement means these are going to be independent. So the probability of red and then purple, the probability of red and then purple is going to be, well, first, what's the probability that you get a red one? And then what's the probability that you get a purple one? So red is going to be 4 out of 10. Purple is going to be 2 out of 10. Multiply these out, you get 8%. And there we go. We already covered that. Let's do another example, okay? If we draw jelly beans again without replacement, this time without replacement, so now it's going to be not independent. What's the probability of doing a green and then a red? So now it depends. So first, we have to get a green jelly bean, which is 3 out of 10. So first, we have to get a green jelly bean that has a probability of 3 out of 10, but the red jelly bean is not 4 out of 10. okay, the probability of a red here is not going to be 4 out of 10 because it depends on the first event. We're not replacing. As soon as I've picked out a green jelly bean, there's not even 10 jelly beans left anymore. How many are there left? After I've drawn a green jelly bean, there's only 9 now. How many of those are red? Well, I took out a green. There's still 4 red ones. So this is where things get a little bit more complicated, something called conditional probability here. So in the next video, we'll talk about conditional probability. And the second one is the probability of a red one given that the first one was green. Conditional probability right here. But in the meantime, we're just kind of introducing it a little bit. This is going to be 12 over 90, which is going to be something. 12 over 90, 13.3 repeating percent. We can round, or you can use the bar, right? You could write 13.3% right there. Or you can round. I'll take either. Or you can have it as a reduced fraction. That's going to be 4 out of 30, or 2/15, I think. So next one, if we draw jelly beans again without replacement, it's not independent. What is the probability of choosing a purple and then a green? So again, the first one is normal. It's just going to be regular first one, probability of a purple, and then multiply that by the probability of a green one, given that the first one was purple. This right here means given. Given that the first was purple. I'm going to have to become a ghost again. Or I could scroll down. Now you can see it this way too. Okay, so this is the notation that we're going to use in the next video. But it functions the same as the previous example. What's the probability of getting a purple one the first time? Well, the probability of getting a purple one the first time is just 2 out of 10. Times, what's the probability of getting a green one the second time? Well, we've already picked out a purple one. So there's only 9 left. How many greens? 3. So we get 1/5 times 1/3 should be 1/15. That's 6/90. Both of these numbers are divisible by 6. That's 1/15. Or whatever percent that is, like 6 point. Hold on, I'm definitely doing math in my head right now. 1/15 is about, that's interesting. 0.06 repeating. That's what I thought, actually, because it's half of the other one. But it's kind of weird. Anyway, I can figure out my issues after recording this video, but we can summarize this by looking at this fact. For dependent events, and again, just like in the addition video, remember, in the addition video, I'm getting excited. In the addition video, the OR video, or addition, there were 2 properties. One, if they were disjoint, mutually exclusive, and the other one that had an extra piece if they weren't disjoint. And I said they're really the same formula, because if, that last piece, this last piece up here is 0 if they're disjoint. We have the same issue here. If they're independent, we have this formula. If they're dependent, we have this formula. But it turns out that these are actually the exact same formulas. Because if they're independent, then the probability of B given A is just the probability of B. Again, that's touching on something in the future. But again, these are really the same formula. But you just have to be very careful on whether they're dependent or independent. This second one will always work. just like the second one and the other one would always work. This is very important. This is the one you use if they're dependent. And again, we'll talk about conditional probability in the next video. So small comment on replacement to finish out this video. And it's known as the 10% condition. We'll talk about this a lot more in the second half of this class when we really start getting into some more complex topics. But in this probability unit, we'll briefly mention it. So if we ever sample less than 10% of the population, then we can assume that the probabilities can be independent, okay? Because it's low enough. Like, right, the population's big enough that we can assume independence here. But if the population is like more similar in size to the sample, then we can no longer assume that. So as an example, let's say we were looking at all Americans. I wanted to find the probability of selecting 2 Americans with blue eyes, given that 17% of Americans have blue eyes, and there's a population of about 330 million. Okay, well then, if we're sampling less than 10% of this population, then we can assume it's going to be independent. And that's pretty much everything I want to say about this. Enjoy. Have a moment of silence for this video at the end. A little bit of moment without math, maybe. All right. See you in the next video.